We're doing a unit now on intermolecular forces, and we've been talking about what makes things solids and liquids and gases, and we're going to talk today just about liquids and talk about the difference in intermolecular forces between three liquids. I thought I had an extra graduated cylinder here. Jamie, do you know anything about that?
I've got a graduated cylinder.
Jamie? That's lovely. I was looking for one that was filled with a liquid.
Oh, I think I have that one.
Oh, okay. Thank you.
Maybe
All
that
right.
one.
Thank you very much. Now we have three graduated cylinders that are filled with a liquid. Okay. What I have in here are these three liquids. I have isopropanol. I have propylene glycol or propane diol, it's also called, and I have glycerol. All three of these are 3-carbon chains. All three of them have alcohol groups on them. All three of them should exhibit hydrogen bonding. Now the difference between them is that isopropanol only has one alcohol group on it. Propane diol has 2 alcohol groups on it. Glycerol has 3. And I tell my kids that when you have hydrogen bonding, it's not as strong as a covalent bond. It's almost like the molecules are holding hands with each other. And I actually will, at this point, often go out into my students. I'll have them hold hands across 2 aisles and try to walk between them. Because what I'm trying to get to here is that the more hands they can hold, the harder it's going to be get through the liquid. What I'm going to use to get through the liquid are these 3 blue spheres. Okay? Now, I'm going to tell you, and I'm not going to tell my students, that I cheated. One of the liquids, the glycerol, is so viscous that it's very slow to get the ball to drop through the liquid. So I've made that one just a little bit heavier. Actually, it's almost twice as heavy. How do I know how heavy to make them? I play with them. What I did was I took some, and you can actually get these from Flynn through another kit. I took some balls that'll open up. I don't know if you can get that. And I put some copper BBs inside until I was happy with how fast they were falling through the liquids. If you have metal BBs, they'll tend to go a little fast. The plastic ones are probably too slow. There's a lot of issues with finding the right spheres for this. The magnetic ones that come in the Flynn kit called Keeping Your Eyes on the Ions are okay. They're just a little too heavy for the propanol. They'll go too fast. So play with them a little bit and see what you can find that's going to fall well. Another issue is depending on the polymer that the balls are made out of, they could dissolve in one of these, in the propanol. So these tend to work pretty well, and I've already got them set the way I want them. You are going to need at least one extra hand, so I've got my assistant to come up here. The idea here is to see which liquid is more viscous, or which liquid is holding the most hands, as I say. Which one is it going to take the spheres to fall which one's going to slow them down the most, and which one are they going to be the fastest? Going back to our chart, I refer to that quite frequently. We've got the propanol has 1 hydrogen bond between each molecule. The propylene diol, propylene glycol, makes 2 hydrogen bonds, 2 hydrogen bonding sites. Glycerol has 3. Okay. So, we ready for the race? I'm going to say 1, 2, 3, drop. So when I say drop, you drop it. Okay. 1, 2, 3, drop. Okay. So the propanol is all the way down. Propane diol following quickly, and the glycerol, having 3 hydrogen bonding sites, takes the longest. Again, that one was a little bit doped. It was about twice as heavy as the other 2. If you want to wait, if you want to take your time, go ahead and have them all the same mass. Okay. One of the tricks I do, I don't do this in graduated cylinders. I keep these in capped test tubes, and I just use them every year. I pick up the test tubes, and I get a helper, and actually I can get 3 helpers on this, and they just turn them upside down, and we time how long it takes. That way you don't have to set them up and take them apart every year. It's more important then that you find material that's not going to dissolve in your solvent, because if you're going to keep these for year after year. You can make them longer if you have long cap tubes, or shorter, or however it's going to be. But I like this. It's quick, especially if it's in a cap tube and you can just keep turning them over, pull them out for many different times during the year. So we've talked about hydrogen bonding in 1 site, 2 sites, and 3 sites on a molecule. Thank you.